Most of the people don't realize this. The way you structure knowledge changes the answers you get from AI. Right now, everyone is prompting AI, but very few people shape the way AI actually reasons. And this is where the real advantage is. And this is where reasoning maps can be super useful. Because whether you're researching, learning, or building, the difference isn't access to information. It's how that information is structured into reasoning. Once you understand that, you operate at a completely different level of intelligence. I've been building Infranodus, a knowledge graph platform for thinking and research, for the last 10 years. And I've been studying how the structure of connections can shape what you can do with information. And this, the reasoning maps for AI, is one of the most underused ideas I've seen in the field so far. There is a way to take any framework, a book, a methodology, or even your own thinking, and to turn it into a map that AI can navigate, so it can become an expert in this field in just a few minutes. Instead of giving AI a prompt, you give it a map, a network of concepts, relations, and rules that shows it how to reason through a problem the way the original framework does. Why does it work better than telling an LLM act like it read the book? Well, first of all, because a prompt is a suggestion. The AI might not even have the book in its training data. And even if it does, it will just extract a general summary of the main ideas inside. A reasoning map is something different. It doesn't just tell your AI what to think, it also tells it how to think. And there is another advantage of having a reasoning map. You can actually see what's happening inside. You can get an overview of the reasoning rules and adjust how they're related to one another. You can connect some ideas that you feel are disconnected, or if you feel like there is too much bias on certain central concepts, you can also build the periphery. It's like becoming a brain surgeon who customizes the connections inside the brain of the AI expert that you will be using to resolve a certain problem. And this is how you also can get the most optimal results. So if you work with complex problems, this approach can help you build an AI expert in minutes. And then you can connect it to your favorite LLM, Claude or NA10, and then use it to apply any reasoning logic you want in any context you need. Let me show you how this works in practice. I will take a well-known negotiation framework, getting to yes, and then build a reasoning map in real time and apply it to a real-life use case scenario. Let me first show you the result that I get with the standard LLM workflow. So here I have a question. I say, use the framework of getting to yes and tell me what to do when my client wants to lower the price for the service I provide. So that's a very simple question. I tell it to use that framework. It has it in its training data, so Claude is providing me a really nice general overview of the main ideas from the book and also tells me how I can apply them to my situation. So it's telling me, for instance, to separate the people from the problem, to focus on interests, not on positions, invent options for mutual gain. These are really good summaries of the main ideas in the book, but it doesn't really apply to my situation. So I tell it, okay, she says that it's not about the budget, she has counter offers from my competitors and doesn't want to budge. So this is a bit more specific, right? And then Claude is providing me a response. Okay, so you can resist the urge to immediately match or counter, acknowledge and validate without conceding. So the kind of nice general advice from the book. If you know what the book is about and you know the framework, you know that it's pretty spot on, right? But it's also very general and generic. Like, I know all this stuff already and it doesn't give me a really concrete way to implement it. Here, I have another example where I ask exactly the same question, but now I'm using the reasoning map, which I created here, which you can see right now on your screen. So the reasoning map here is used in Claude through the Infranodus MCP server. And then, as you can see, Claude is retrieving that graph, the getting to yes graph from the expert user from the knowledge base here, right? So it makes a request. And then the response has the information it needs to combine all these different reasoning rules into a response. And here it gives me a nice overview, almost the same as I had here. But the advantage here is that it also picks up on some smaller cluster, which is pretty interesting, which says, watch for dirty tricks. So see how you might be manipulated. Maybe this offer to lower your price is just a trick to get you to concede to some conditions that you're not so interested in. So this is actually pretty good because it caught on something that the general overview didn't really pay attention to. And this is one advantage. But here, when I go deeper and I say the same thing, okay, she says it's all about the budget, she has counter offers from my competitors and doesn't want to budge. Pose this question to the graph, to the expert, to the AI expert graph that I have here, and then tell me which results we get. And here it's using the MCP server again. it asks this question to the graph of getting to yes, so it consults the AI expert. And then what happens here is that it provides a response, but when you look at this response, you'll see something really different, because instead of just giving you a bullet point list of the general ideas from the book, once again, it's actually giving me concrete strategies that I can implement into my negotiation. And this is because the actual rules are encoded here as relations that are very precise. It's an ontology of reasoning in that particular framework, and so it's applied directly here. So you see from this example, it's telling me test whether her batna, it's the best alternative that she has, is real or a pressure tactic. And then it's explaining why it came to this decision, because it's seeing the relation between the different concepts inside the graph. So it's telling me there is a whole cluster in the original expert graph on positional pressure tactics, which include extreme demands and escalating demands, and the competitor counteroffer can be genuine, or they can be a form of deliberate deception involving phony facts. So it took this part of the reasoning logic here and understood that maybe my situation is an example of that, and then it's providing this advice to me to help me approach the situation in a completely different way. Here it's also giving me another advice, shift from zero sum to the pi expansion, and it's explaining exactly which rules it used in order to give me that advice. And here you can see really precisely that it took a certain logic, and then it says that the graph connects insist on objective criteria, and then it moves to fair standards, market value, precedent, and scientific judgment, and then it's interpreting this rule by telling me that instead of matching her position, you say, let's look at this objectively. Here's what the market rate is for the scope and quality level. If the competitors are offering less, are they offering the same scope? So really kind of trying to counter it on the scope of the service provided. So as you can see, it's really precise, and it reveals the reasoning rules that it's using. So the response will be much more nuanced and much more specific. Let me show you how it actually works under the hood. So here I create this graph, the getting to yes graph. And in order to do it, I can actually go to the apps page inside Infranodus. And then when I click on add a new text, I can click on this option, AI, generate a graph, and then I can tell it what topic I want to explore. So in that case, it would be, for example, the negotiation framework of getting to yes. All right, so I click visualize, and what happens under the hood is that Infranodus, it extracts the reasoning rules about this framework from the knowledge that it has. And if it didn't have this book and its training data, you could actually provide the context in the prompt. So you can also create experts on some really custom reasoning rules that maybe are not in the training data. And then it builds a graph like this with the main principles and how they're connected to one another. So for example, if you know something about this framework, you will see that it's talking about the best alternative and how it's connected to the concept of walkaway point. And if you click here, you can see that the best alternative determines the walkaway point of a negotiator. And then it also describes the connection. So you see it's building this kind of ontology of different rules that exist in this framework. If you click, for example, on underlying interests, you see everything that underlying interest is connected to. So for instance, if I click on underlying interest, what's the relation to security needs? It tells me underlying interests include security needs, economic well-being, and the sense of belonging. So this is something that helps you negotiate and get to the actual needs that the person has rather than to the surface demands. So you see, it makes a sort of visual summary of that framework. And the advantage here is that you see all the rules. You can also edit them. You can optimize this graph structure, because when you go to the analytics panel, you can see here that the topical diversity is low because there is too much focus on principal negotiation here. And maybe you need to evolve other clusters as well. So you can actually also build on top of this graph by seeing that maybe some of the concepts that it didn't connect are actually connected. And you can either do it manually just by analyzing this structure like a brain surgeon, what I was talking about before, and seeing, for instance, okay, maybe there is a relation between brainstorming and distributive negotiation, for instance, and what that connection could be. Or you can use the automatic recommendation from Infranodus itself, where it says, okay, you have the gaps here between the cluster of interest-based and fair standards. And if you click on AI question here, then it's going to use the built-in AI module to generate some of the ideas based on these clusters. And then when you ask it to elaborate on this question, then it's going to generate a statement which you can add into the graph and then enhance the whole range of concepts available here and make them much more precise. So you see, I added something here, and now we have this cluster a little bit more elaborated, and so it becomes a much more detailed and much more precise. You can do it manually or automatically as you're interacting with this graph and as you're researching using this graph, right? So then you gradually build a reasoning logic like this. By the way, you can also do it completely manually. For some of my favorite use cases, I actually build a manual graph, which you can also do if you go to the apps page and add text and then you click on knowledge graph. So you can use wiki links. It's a syntax that's used in tools like Obsidian, for example. So I can type in BATNA is a negotiation tactic, and then it will make a connection. So you see, you can also build it manually like this, step by step, and then use the statement editor here to add more rules. Usually it would take you maybe an hour, but you would have a really high quality reasoning expert. And then basically once you have something constructed, like I have here, the final result, more or less, my getting to yes graph, then I can expose it to my own account through the MCP server inside Claude. So I have another video on how you connect MCP servers, but basically it's the connectors that you can use here. So you connect Claude to your Infranodus MCP server, and then once you have it connected, you can actually use it to query the different expert graphs that you have, or you can also query public graphs. So for example, the account I have here, it actually exposes some of those reasoning logics to the outside. So I have public graphs on the Getting to Yes framework. I also have, for example, here, Ray Dalio principles. And what's great about that is that now I can use this other reasoning framework of Ray Dalio and apply it here in my negotiation tactics. So for example, I can say, now use the graph Ray Dalio principles from the user expert, because that's the user that is providing this knowledge, to add some ideas here. I can be also very general like this with my request. And then what's going to happen here is that Claude, through the Infranodus MCP server, will now query this graph Ray Dalio principles from the user expert. It's public, it's exposed, so it's available. And then we add this reasoning logic into this thinking process. So what's great about this is that you're also combining different brains together. You can combine, in this case, the Getting to Yes negotiation framework with Ray Dalio's principles. Maybe you have your own graph. So basically, if you have many different graphs, you can combine them together. You can also expose them to other people and then make your AI have access to all these different reasoning logics and different brains, and then combine them together and make them work for each other. So I think this is a really nice approach that you can use in your research and conversations with AI as well. And by the way, if you like, you can also use it inside NA10. So we have even a template on the NA10 website where we demonstrate how this framework works when you want to build a network of experts. So basically here you have a chat message arriving to AI agent. That's a node from NA10. And then it's connected to several experts in different fields. So here I have an expert on 8OS. It's a movement practice, and then polysingularity. It's more of a thinking practice, but they're both based on variability, but they approach it from different perspectives. And so each time the request comes here, the agent will consult these two experts, and then it will provide a response based on what both of them say. And then the result that you get is pretty interesting and very nuanced. And also what's great is that it combines different ways of thinking and then proposes you something that will incorporate all of them. So that's really great. And as you can see, you can use it inside NA10, you can use it inside Claude, or if you use Claude Code, you can also use it inside Claude Code. And finally, if you want, you can also actually interact with this graph inside the Infranodus tool itself. So if you go to this graph and you open the AI module, then you can also ask these same questions directly in that graph, and then it will provide the responses for you. So I can say, for example, my client doesn't want to pay the price that I propose. What to do? Very simple question like this. And then what's happening here is that Infranodus, under the hood, it's basically traversing this graph, all the logics, and then it provides you the response based on this logic. So you can also interact with the graph inside the graph itself. And if you expose a certain reasoning logic, then you can have other people interacting with your graphs. So here on the main side of Infranodus, we actually have the graphs page where you have reasoning ontologies. And so when you go there, you can actually interact with any of these public graphs. So for example, we have one on Chinese medicine. We also have Ray Dalio's economical principles, but we also have even a tarot ontology. So you can do like a tarot reading through this graph, and you can do it inside the interface itself or through your favorite LLM, or even inside NA10 by connecting it to your own workflows. So this is how it works. I hope you find it interesting. Let me know if this approach sounds useful to you, if you try to apply it for your own workflows and what your results are. And if you have any questions, please leave a comment under this video. I read every one of them and I will be very happy to respond. Thank you.